Welcome back, mathematicians. Today we're going to dig into function notation, what it means, and how to work with it. You've probably seen things written like f of x, or g of x, or even h of x, and even more complicated forms. But what do these symbols really tell us? In this lesson, I'm going to walk you through 3 examples, starting simple with just a constant, then moving to a monomial that has a different variable being plugged in, and finally moving to a binomial that has this entire binomial plugged in. If you want to start from the beginning, great. But if you have a question on your homework or an upcoming quiz or test that's more like one of the later ones, I have all of the chapters in the listing below. Let's get started. First of all, let's talk about what this means. We say this out loud as f of x, and it means a function, this is a function, in terms of the variable x. And you'll notice that it has the variable x in the function itself. You can also think about this as y equals 4x squared minus 7x plus 5. This is the way that you've probably seen it up until now when working with equations, solving equations, and graphing equations. It means the same thing. It's really convenient to start to use function of x because we can have multiple functions such as g of x, h of x, and actually start to do operations between these functions. Now, we're not going to do that in this video. In this video, we're just going to figure out what exactly this means and how to evaluate it. So we've been given this function f of x, and we've also been given another qualifier over here, f of 3. This is really actually quite easy. You just need to think about that 3 as x equals 3. Because this is a function in terms of x, they're saying plug 3 in everywhere you see x. So we're going to begin by doing that now. So since this already had parentheses around the x, I'm going to erase the x and plug in 3. That's what I recommend that you do with the rest of this function as well. I'm going to copy it down right below. You would copy it on your paper. My recommendation is to put parentheses around every variable. And in fact, to make that just a little bit easier to see, let's put it in a slightly different color. The reason that I want to make sure I'm putting parentheses around just the variable is because this square is going to apply to everything that you see, and the 4 is going to multiply after it. So we don't want to get confused with what we're actually substituting. Now, in each of these cases, I'm going to erase the x and insert the number 3. This is a simple matter now of just evaluating, going through my order of operations. The first order of operations is going to be this exponent. The 4 on the outside stays the same, and remember this means 2 copies of whatever is in here being multiplied together. 3 times 3 is 9. Now, because this is a separate term, I can save myself some time by going ahead and multiplying this as well. In my next step, I have multiplication, subtraction, and addition, and I have to take care of that multiplication first. 4 times 9 is 36. And I'm going to copy the rest of this down so that I don't lose track of what's in there. Finally, I can finish simplifying this by doing the subtraction and the addition. Be very careful. A common mistake here is that students will go straight to the addition and try to put these two together. But addition and subtraction, just like multiplication and division, has to be done from the left to the right in order. 36 minus 21 is 15. And then we're going to bring down the plus 5. So finally, f of 3 is equal to 15 plus 5, which is 20. And that's my final answer. Let's go and try one that's a little bit harder. Now this one has a different letter. g of x. The reason that we use different letters is just to distinguish between one function from another. If we called them all y equals, then when we listed them, we're essentially saying that they are equal to each other, and they are not. These are two totally different functions. But they're going to solve exactly the same way. Because this says g of 4y, we're going to take 4y and plug it right back in. Now, you might have asked yourself on the last problem, and you might be asking yourself on this one, why do we have a semicolon here? I didn't address that in the previous one, so hopefully if you had that question, you stuck with me. This semicolon doesn't do anything except separate the function itself from how we are to evaluate it. It's just like when we use it in a sentence, it separates two parts of the sentence. You can essentially ignore it as if it's not there at all. We're going to write this function down on our paper. As we go, we're going to put parentheses around every variable, just like this. Now this tells us to erase every single x and put in 4y. That might be just a little bit confusing, but it doesn't have to be. We're going to just place 4y in here now and see how it goes. What do each of these parts mean? So the g of 4y just gets copied down because it's just telling us what did we do to this function. We plugged in 4y. And we're going to look at each part on its own. Remember that an exponent means I have 3 copies of everything that's inside the parentheses. So my side work could be 4y times 4y times 4y. 4 times 4 times 4 is 64. And y times y times y is y cubed. So right inside of that parentheses, I am going to put 64 y cubed. Minus 4y. Now I can multiply that 2 into the 64. On my next line, I have g of 4y equals 128 y cubed minus 4y. I'm going to do one last check and see if there's anything else that I can do to simplify this or combine it, and I cannot. So in terms of evaluating, I'm done. However, some teachers may ask you to go ahead and factor this as well. If they have, you'll want to take out a 4 and a y and divide 128 divided by 4, which gives you 32. That leaves 2 y's left over minus 1. So this is the factored form of the same answer. Let's do one that's even harder. You'll see right away that what we're putting in for the variable x is a much more complicated expression than a simple constant. I know I'm going to need a little bit of extra room, so I'm going to write it just a little bit slower. Every time I have an x, I also know that I'm going to need some extra room for the expression that's going to go in there. So when I copy it down on my paper, I'm going to make sure to leave some big spaces where the x's are. So I'm going to erase all of the x's and put in 2m minus 1. I didn't leave myself enough space in the beginning. Now, first things first, I want to figure out what does that mean. Remember, it means 2 copies of everything that's in this parentheses. So my side work over here is 2m minus 1 times 2m minus 1. Remember that this is multiplying binomials. 2m times 2m is 4m squared. 2m times negative 1 is negative 2m. 2m times negative 1 here is negative 2m. And negative 1 times negative 1 is positive 1. So we're going to combine that together to make negative 4m in the middle. If this was at all confusing, you're going to want to watch my video on multiplying binomials as part of quadratics and factoring. Now we're going to go ahead and plug this in. I have 4m squared minus 4m plus 1. I can go ahead and take the time at this point to distribute this 2 to the two things that I have in this parentheses. So 2 times 2m is 4m, and 2 times negative 1 is negative 2. And this negative 9 hasn't done anything with anyone yet. There's no parentheses, so we're just going to break him down. Finally, it's time for us to combine anything that is a like term. Remember that m squareds can't go with regular m's, and there's only one term that has an m squared, so I'm just going to copy it down. I have a negative 4m and a positive 4m, so I'm happy they cancel each other out. And now I have a 1 minus 2, which leaves negative 1, minus 9, which leaves negative 10. Now again, this would be the end of our answer, unless your teacher has asked you to factor it. In this case, 2 is what they share. They don't share an m. 2 goes into 4, 2 goes into 10, and so what I have left is 2m squared minus 5. And this would be my factored form. I hope this helps with the 3 different examples of function notation. Don't forget to subscribe or like below and reach out if you have any other questions.